Hello everyone, welcome to the live class. So guys, today we are having another very important session in which we are going to discuss some more very important questions for your upcoming GATE and CSIR NET physics exams. So I hope that the discussion which we have done in our previous classes, that will be clear to all of you. Even the discussion which we are going to do today in this session will get clear to all of you, and with these important questions you will be able to prepare many important concepts. You will get to know about the right approach for solving different type of questions in this session today. So first of all, before starting the discussion, please confirm it to me that whether everything all right, like the audio, video, slides, everything fine or not. And I'm just going to check your comments here till then. Okay, and after your confirmation, we are going to continue the discussion. We are going to start the discussion about the questions and the many important concepts which we are going to cover in this session today. Please confirm it to me in the comments whether everything all right or not. Gonna check your comments here. Is everything all right? Audio, video, slides, everything fine? That's very good, Mariam. Okay. That means we can start the discussion then. Okay. That's good. Okay, so guys, in the starting I'm just gonna take some time to let you know about some of the updates related to Unacademy Plus subscription and related to the GATE and CSIR NET mock test. These mock tests are gonna start soon, so I will provide you some information about these points first, and then we are gonna continue the discussion. We are gonna start the discussion about those questions which we will discuss in this session. So guys, as you all know that on Unacademy Plus, many important courses by all the top educators are going on right now. Even many new courses are gonna start soon. So if you want to attend the live classes of all these important courses by all the top educators we are having on Unacademy Plus for your upcoming CSIR NET and GATE exams preparation, then you can take the Unacademy Plus subscription, and by using and by applying the referral code, which is Anjali Arora, as mentioned here, you will be able to get the 10% discount in the total Unacademy Plus subscription amount. All these Unacademy Plus courses by all the top educators will help you a lot to prepare very well for your upcoming CSIR NET and GATE physics exams. Clear? Even you will get to know about many important concepts, tips, tricks with all these sessions we are gonna have here, okay, in these courses which we will cover up. Also guys, one more update is here related to the GATE and the CSIR NET mock test. Okay, so they are gonna start from this week now. So on Saturday, that means on 9th January, we are gonna have the GATE physics exam mock test. This is the free test for every one of you. You all can join this test. You can enroll in the test too. Also, we will have the analysis session of the test on the 9th January, same day, okay, in the evening, that is at 6 o'clock. So guys, you can even join that analysis session. In the description of this video, there will be the link to enroll in the test, so you can even enroll from there. Okay, and one more information, that as you all know, there was like update regarding the price hike. So now it has been delayed and it has not taken place yet. So even if you want to take the subscription right now, you can take the subscription before there is gonna be a price hike for the Unacademy Plus subscription amount. And as I have provided you this information earlier as well, that you can use and apply the referral code, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write it and apply it. Okay, and the another update related to your CSIR NET mock test. So they are gonna start from 10th January. The timing of the test will be 10 AM. And here for the GATE exam, the test timing will be also 10 AM, but it is on 9th January. Clear? So that's how you are gonna have the mock test for your CSIR NET and GATE exams. Clear? I hope everything will be clear to all of you now. And guys, one more thing, let me know, are all the things which are on the screen, because I will write something right now, and please let me know, is it properly readable and clear to you? See, because if it will not be clear, I will just try to make it clear first, then we are gonna continue the discussion. Is it clearly readable? Very good afternoon, Kaku. Like in the last class, I think somebody was facing difficulty in reading the things I was mentioning on the screen. So please let me know, is it clear right now? Or is it not clear? If it is not clear, we will just... Akshay? Is it fine now? The first one or the second one? Which one is more better? Which one is more better? First or the second one? The second one? Okay, let's consider that same. Okay. So guys, now let's start the discussion. I'm going to give you the first question for this session today. And one by one, we are going to take many other questions. If you even don't know about any concept, if you have not prepared this topic, that is Lagrangian or Hamiltonian till now, even along with that, we will consider the rest of the topics which we are having in these topics. You can call them the subtopics. We will consider all of them. Clear? So here is your first question for today's session. And every one of you should try to solve these questions. The first question is from the previous year's GATE exam, that is from GATE 2019. Okay. The question is, the Hamiltonian for a particle of mass m, the Hamiltonian for a particle of mass m, this is from GATE 2019, of mass m, clear, is h is equal to p square upon 2m, p square upon 2m plus k q t. Okay, where q and p are the generalized coordinate and momentum. What is p here? Generalized momentum. What is q here? Generalized coordinate, respectively. T is the time. I'm going to tell you here itself. T is the time and k is a constant. P generalized momentum, q generalized coordinate, t time and k constant. Okay. For the initial condition, that is gonna be q is equal to 0 and p is equal to 0, clear, at t is equal to 0, at t is equal to 0. The value we are having for the q given to us, which is gonna be qt is equal to, t is proportional to basically t to the power alpha. Qt is proportional to t to the power alpha. The value of alpha is dash. Okay, just try it now and let me know once you will get it done. And if you don't know about the approach or the steps you need to take to solve it, I will let you know. But try it first, okay? And before, okay, once you are gonna get the answer, you can mention it in the comments. One more information, guys. As you all know, in this month, that means in January, we are gonna have many special classes. So, almost regularly, okay, if there are gonna be any changes, and if you are regular in the sessions, you will get to know about those changes. But right now I'm gonna conduct the sessions. These are the special classes, which means the free live classes on Unacademy learning app. So the timings are 1 o'clock in the afternoon and 6 o'clock in the evening. So today we are gonna have these two sessions of electromagnetic theory. Okay, exactly after this class at 1 o'clock we will have our another session. Okay, that's gonna be on electromagnetic theory, and the 6 o'clock session today also on electromagnetic theory, and both are free sessions. If anybody is going to join these sessions for the first time, they will have to use a code that is same as the referral code as I have shown you here, that is Anjali Arora. So to join the free classes also you will have to use a code that is same as the referral code. This referral code also provides you the 10% discount in the total Unacademy plus subscription amount when you take the subscription, or when you are gonna join the free session for the first time, that is a special class, then also you can use that code. Okay, let me know once you are gonna get it done and mention your answer in the comments. Very good, Kaku. One answer there. And guys, as you are gonna get the answer, please mention it in the comments, then I'm gonna start the discussion too, if there will be any doubt or difficulty anybody will have. Only one answer till now. Waiting for more answers. Very good, Ritika. What about others? 2 answers till now. What about others? Okay, can we start the discussion for this question? What about others? Because 2 answers till now we have got. So either you are having some difficulty in solving it or you are doing it. So please mention it in the comments and let me know. Can we start the discussion or are you still solving this question? I think either I'm not getting the comments. Just a second, let me just check, guys. No, only 2 answers are there. Very good, Neeraj. That's good, good, good. Okay, let's start the discussion, guys. Clear? Because only 3 answers we have got regarding this question. Basically, the first thing about the question is that what is the data they have given, what they are asking us to find. So they have given us the Hamiltonian. Okay, they have given us the Hamiltonian, and after that they are asking us to find what? Let's have a look at the next statement. Hamiltonian given for the initial condition. Okay, they have given us some conditions here. Okay, qt is proportional to t to the power alpha. So what we need to find? We need to find the qt expression. That means what is the expression of q in terms of t, and what is the power of t there? That's what we need to find. Now when the Hamiltonian is given here, you need to think in this manner. How many formulae related to Hamiltonian you know which can help you to get the value of q? Okay, how many formulae are there? So in the Hamiltonian you know h is equal to t plus v. Then you know the Hamilton's equation of motion, that is q dot and p dot equations. Then you know some more relations like between the Lagrangian and Hamiltonian. Okay, like that. So mainly these 3 are the most popular formulae from the Hamiltonian part. Okay, or the like directly related to Hamiltonian. So which one is most suitable? Is that h is equal to t plus v, or is that Hamilton's equation of motion, or is that the relation between Lagrangian or Hamiltonian? So if you have prepared this topic, you will be familiar with all these formulae. Now the choice is yours. What you are gonna select. Clear? So here I am gonna prefer to start solving it by using the Hamilton's equation of motion. Why? What is the reason? Time is involved in the answer. Okay, or we need to get the relation with time. So what will happen in this case? When I'm gonna start solving it by considering the Hamilton's equation of motion. Okay, I know that the equation of motion are what? A second. See, we all know that it's gonna be q dot is equal to delta h upon delta p, where q dot is what? It's gonna be dq upon dt you can write, or delta q upon delta t you can write. Okay, from here the t will be involved in the expression. In the same way, the second equation of motion is, that is gonna be p dot is equal to minus delta h upon delta Q. Here P dot is what? That is gonna be delta P upon delta T or dP upon dt you can write. Done. Now Hamiltonian is already given. So let's just simplify it. What we will get? Delta H upon delta P will give us 2P upon 2M. So we P upon M only. Clear? And that is equal to what? dQ upon dt. When you will simplify it from here, after cross multiplying and after integrating, what you will get? You will get Q is equal to PT upon M. Okay, this is what you are gonna get. Now here it is gonna have P in this expression. So we know that second equation will give us some relation of P with T, that is time. Clear? So we should firstly simplify it because Q is dependent on P and T both, and if P will be dependent on T, then we have to consider that relation here to get the overall dependency of Q on T. So let's check out the second equation first and then we will finalize our answer. So it will be dP upon dt, dP upon dt, which is equal to minus delta H upon delta Q. So here is the Q, it will give us K into T. Okay, so minus KT. Now cross multiply and integrate. What you will be able to get from here? You will be able to get P is equal to minus KT square upon 2. Okay, and here you can even consider the integration constant. Here also we should consider the integration constant. I am calling it C1. And this one, let's take it as C2. And why we need to take the integration constant here? Even you can see that they have given us the conditions. These are the initial conditions or the boundary conditions, which are Q is equal to 0 and P is equal to 0 and T is equal to 0. So all the three you can put 0. So P, Q and T 0 will give us C1 0 here. And P, Q and T 0. So here P and T are present. Okay, at T is equal to 0, P is also 0, which will give you C2 is equal to 0. So when C1 and C2 0, you can directly just remove them from here. They are gonna be 0. Clear? Next point. From here you have got to know Q is equal to PT upon M and P is equal to minus KT square upon 2. So just you need to observe the dependency on T. Put the value of P here. It will have T square in it. T square into T will give you what? T cube. So here you can get the dependency of Q on T as power 3. Okay. So the answer will be what? It will be 3, which will be your right answer. Is that clear to everyone? If there is any doubt anybody is having, let me know. And if everything clear, that's good. Another thing is always be careful about it. If you are getting some extra term and which can even be dependent on that parameter on which they have asked the dependency. So observe each and everything and then finalize your final answer. Is this clear? And if there is any doubt, you can mention it. You can let me know about it and I'm going to discuss that point too. So please let me know whether it is clear or not. Okay, done. If any doubt, please mention it. Let me know about it. We will talk about that point. And if no doubt, that's good. Here is gonna be your next question which I'm gonna take. Clear? If you will have any question or any query, you can mention it. Next question is here, which is again from GATE 2017 exam. The last one was from GATE 2019 and this one is from GATE 2017. If the Lagrangian that is L0 is equal to half m dq upon dt to the whole power 2 minus half m omega square q square. Omega square q square. Done. Next is modified to L is equal to L0 plus alpha q dq upon dt. Then you need to consider which one of the following is true. The options are which one of the following is true. Okay, the options are both the canonical momentum, which is going to be PQ, and equation of motion do not change, okay? And the option B is canonical momentum, that means PQ changes, okay, but the equation of motion does not change. Okay, option C is canonical momentum does not change, but equation of motion changes. Clear? Option D is both changes. That means canonical momentum and equation of motion both. So please let me know once you will get it done which option is correct according to you. If you will have any doubt or difficulty in getting the answer, I will discuss it, but if you are gonna get it, you can mention it in the comments that which option is correct according to you. Clear? So mention it in the comments as you are gonna get it done, that which option is correct according to you. Very good, Neeraj. Neeraj, you can even mention your answer in the comments. Because right now we are not gonna start the poll. So yeah, you can mention it. And guys, this time in the GATE exam, you are gonna have the M.Sc type questions too. So what we can do, instead of writing the options in this manner, we can write like PQ changes, PQ does not change, okay? Then we can write equation of motion changes, equation of motion does not change. So that's how I can make the 4 options. Clear? And then out of those 4 options, any 2 can be correct. Then again, it will be what kind of question? It will be M.Sc type question, okay? So I can even make the changes in these options and it will become M.Sc type. But right now, let's keep it same. I'm just telling you that how the M.Sc type questions you can get. Clear? Very good, Neeraj. Very good, Kaku. Very good, Arindam. Right, Kaku. That tick shows it changes. That cross shows it does not change. Clear? Very good, Ritika. Done. Okay. So 2 different answers till now, option B and option D. Let's start the discussion about it. Is it clear to everyone? Or anybody is there who is not getting it? If no, I'm going to discuss it because one answer is even different. Clear? So we need to talk about that. So let's start the discussion, guys, so that after completing this one, we will be able to talk about the next one. Basically, here they have given us one Lagrangian. They denoted it with L0, and then they said like, okay, we are going to modify this Lagrangian. We are going to add something in it. We are going to make some changes in it. That kind of modification is taking place. So then after modification, this is the new Lagrangian we are going to have. Now what is going to happen? They are saying like, okay, when we have modified the Lagrangian, what kind of changes will take place? Will the momentum remain same, that is the generalized momentum, or will the equation of motion remain same? So we need to check that thing. For that, the first thing everybody needs to know is what exactly is the formula for the generalized momentum. If you know that, that's very good. Okay, if you don't know that, you should know about it. I'm going to let you know right now. So basically, the generalized momentum is PQ, which is going to be delta L upon delta Q dot. Okay, Q dot here, you can replace this dQ upon dt with Q dot and you can take its square. And here, again, this dQ upon dt is what? It is Q dot. So first of all, we will check for the L0 Lagrangian, that what is the generalized momentum. Then we will check it for L. Okay, so one by one for both. And if we are going to get it same, that means it does not change. Let's have a look at this. If I'm going to find it for the first L0, okay, what will be the value you will get. Delta L upon delta Q dot. Clear? So 2Q dot will be there. Okay, MQ dot only. We are gonna get MQ dot from the L naught part. But what about the L? If I will find PQ is equal to delta L upon delta Q dot, what will happen in that case? We will be able to get, see, L naught will give us what? It will give us MQ dot. Okay, MQ dot. It is gonna be MQ dot. What about the second one? Because L naught is involved here, so from there we got MQ dot. Q dot is also here. We will get alpha Q plus alpha Q. Is it same? No, it is changed. Okay, so now in this case we can say PQ is not same. When PQ is not same, it means PQ changes. When PQ changes, it means the tick tick part. So that is either option B will be correct or option D will be correct. Because option A and C are saying that they are not gonna change. That means PQ is not changing. So that is not correct. That is not correct. Only out of option B and D we need to select now. In option B and D, now we have to check the equation of motion part. Because in option B they are saying equation of motion does not change, while in option D they are saying equation of motion changes. So let's check it out, the equation of motion. So for the first part, I'm gonna use the another color here so that you will not get confused about the answer part and the question part. For the first one, I'm gonna write the equation of motion, that will be d by dt delta L upon delta Q dot, this is for the L naught part, minus delta L upon delta Q is equal to 0. Okay, now in this case what will happen? When I'm going to solve it, what I will get? This is what? This is basically PQ. We have already find the PQ for this. It was MQ dot. I will directly use it here. I can write MQ double dot because then we will differentiate it with respect to time once again. Minus delta L upon delta Q. So what will be delta L naught? Again L naught should be here. Delta L naught upon delta Q. We will get from here M omega square Q. And minus minus will become plus. So M omega square Q. Okay. That is going to be equal to what? It will be equal to 0. Okay. This is the first equation of motion we have got for what? For the L naught, the initial Lagrangian which was given to us. In the same way, we are going to check for the modified form of the Lagrangian, which is what? Which is this L. For the second part, we will check now. Okay. If we are going to write it for this one, instead of taking this naught here, I will just have to consider L. So equation I will not write again. That is the formula. We have already mentioned it here. But let's work on the second part. Instead of L naught, now you will write L here. Done. So again, delta L upon delta Q dot, which will be same as this one. MQ dot plus alpha Q. And then you will have to differentiate it with respect to time. So what it will be? It will be MQ double dot plus alpha Q dot, and then here minus sign delta L naught upon delta Q. What you have got from here, that will remain same, which is MS. That will be plus M omega square Q. Okay. And then next part, that is due to this term, the extra term, which you will get from here delta L upon delta Q. Delta L upon delta Q. Okay. Let's just check it out. You will get alpha Q dot from here, but it is with the positive sign, so you will get it negative, minus alpha Q dot, and that is equal to what? 0. This and this term will get cancelled out. You are getting MQ double dot plus M omega square Q, which is exactly same, and it shows that equation of motion does not change. So which option is correct? This one. Okay, that's why option B will be the correct option. That's how you can easily find the answer for any such type of question, and that's how you will be able to do, okay, this one as well. If there is any doubt anybody is having, please let me know. And if everything clear, okay, then we can talk about the next question. Very good, Onik. Very good, Shubhangi. Shubhangi, is that clear now that it will be option B, not option D, and why I have shown it here? Is that clear to everyone now? Done, done, done. Okay. If there is any doubt, you can mention it. You can let me know about it. And if there is no doubt, here is your next question. Okay, that's good. And if there is any doubt, please mention it in the comments. I will explain it. again from the previous year's GATE exam, and all these questions are equally important for the CSR NET exam too. It is from GATE 2015. The question is the Lagrangian for a particle of mass m, for a particle of mass m at a position vector r, moving with a velocity vector v, moving with a velocity that is gonna be vector v, okay, is given by L is equal to, not vector, just L is equal to m upon 2 v square plus c r dot v minus capital V. Now it's not a vector, it is a potential energy expression they have shown, okay, where VR is what? That is the potential, and C is what? Capital C is a constant, V is a potential, capital C is a constant, and rest of the terms meaning I have already mentioned in the above statement. If PC, okay, is the canonical momentum, then its Hamiltonian is given by, so you need to find the Hamiltonian, and the options I will write now. This is the question statement, okay, then you need to find the Hamiltonian. Clear? Options are you can start solving it too. You can just get some hint or some idea from the options, okay, but I think initial steps will be exactly same, so you can start working on them. Okay, 1 upon 2m PC, that is the canonical momentum, CR, okay, that is just multiplied together, whole square, plus VR, V is the potential here. Option B is 1 upon 2m PC minus CR whole square plus VR. Once you will get it done, you can mention your answer in the comments. Option C I'm gonna write here. Option C is PC square upon 2m plus VR. PC square upon 2m plus VR. Okay. Option D is, let me just check whether it is clearly visible. Yep. Okay, that's good. Option D is 1 upon 2m PC square plus C square R square plus VR. Please let me know once you will get it done which option is correct according to you. Very good, Shubhangi. What about others, guys? As you will get it done, you can let me know about it. And if something is not clear to anyone, please mention it too. Okay, I will talk about that point and I will explain that to you. Very good, Arindam. That's good, good, good. Let's wait for others' reply and we'll start the discussion after that. Very good, Kaku. Very good, Mariam. And guys, if it will be clear to everyone, we can directly talk about the next question. So if nobody will have any doubt, we will talk about the next question then. Okay. And if anybody will have any doubt, then don't worry, I'm going to explain it to you. You can mention it in the comments once that it is not clear. Very good, Neeraj. Very good, Naveen. Very good, everyone. What about others? And all the questions we have done, all these questions were from the previous year's GATE physics exam. Okay. So you can get an idea like what kind of questions you can expect. They can ask you in the upcoming exam as well. Very good, Ritika. Okay, Abdullah, let's talk about it then. Okay, I'm going to explain all the steps and everything. Yeah, we are going to talk about it. See, if I'm going to talk about the steps, they will be just basic and simple steps based on the formulae, but we need to solve it very carefully because the calculation involved here, if we will take the right steps, we will get the answer quickly and in less time. If we will take some different type of steps, we may just stuck in the calculation and it can become difficult. So have a look at this, which one is the right one. The question is, the Lagrangian for a particle of mass m at a position vector r moving with a velocity vector v, that is given by, this is the Lagrangian given to us. Okay, this is the Lagrangian given to us. So till now when we have read the question, we need to keep this thing in mind that okay, what they have given, just the Lagrangian. Let's read it further. They have told us that PC is the canonical momentum in the options. Okay, and what we need to find, the Hamiltonian. Okay, that's good. Now let's start working on the process of getting the Hamiltonian from the given Lagrangian. So there is a formula which provides us the relation between the Lagrangian and the Hamiltonian. So here we are going to use that formula. Okay, and what is that formula? Let me just show you. That formula is H is equal to summation over I Qi dot Pi minus L. Okay, this is the formula. So if you know the Lagrangian, by using this formula, you can easily get the Hamiltonian when you know the Lagrangian. Okay, I hope every one of you know about it, but if you were not familiar with this expression, know it now. Whenever you want to convert or you want to get the Hamiltonian and the Lagrangian is given, use this formula. When the Hamiltonian is given and you want to find the Lagrangian, change or interchange the position of Lagrangian and Hamiltonian. You can use this formula once again. Now, what is the Lagrangian given here? Just a second. That is m upon 2v square. I'm going to use it here in this formula. So I will be able to write H is equal to summation Qi dot Pi. What is the Qi dot? The coordinate used here. That is r. Okay, they have not used x, y, z, theta, phi, r, like they have used r. So we will also use r. Even from this expression of potential, you can get an idea that potential is a function of r. So what I need to do for the Qi dot, I will write r dot. Okay, because they have used it as the coordinate. Clear? Even I think in the statement given above, they have mentioned it. See, at a position r. So r is showing the position, and this is also what? Generalized coordinate, which shows x, y, z, r, theta, phi, anything like that in terms of position. P is what? P is the generalized momentum. What is the momentum term involved in the question? That is PC. So we will even write here PC. Clear? Then minus L. What is the L? M upon 2v square. I can write or I can replace v with r dot because we know dr by dt is equal to velocity v. So instead of writing dr by dt, I am writing r dot in place of v. Okay, so r dot is square. In the Lagrangian or the Hamiltonian, okay, you don't need to worry about the vectors part a lot. So you don't need to worry about them a lot. That means you can even simplify just in a very easy manner any such type of question. Okay, every time again and again, even if you don't want to write vectors or you don't want to put that arrow, just because you want to focus on the calculation part, it's okay. But you should know it is present, so anywhere, if it is gonna affect the expression, you can take it back. Okay, but right now I'm gonna just take it in the simple manner. Then what is the Lagrangian next term? It is C r dot v. So instead of taking that vector term, I am writing it in general. C R dot, because I need to differentiate it further, I need to simplify it. Okay, so let's just have a look at the next term. Minus VR, it means minus will become what? Plus. So I'm going to write plus VR here. Clear? Next point. This is the Hamiltonian. Is this expression matching with the given Hamiltonian expressions in the options? Is it matching with any expression given in the option? No. So what I have to do, I have to think like how I can change it. Also, one more very important concept related to Hamiltonian you need to know is Hamiltonian is a function of generalized coordinate and generalized momentum, which is the function of Q and P. Clear? Now, in this case, and the Lagrangian, when we talk about the Lagrangian, it is the function of generalized coordinate and generalized velocity. So here you can see the generalized velocity term is present. We don't want that in the Hamiltonian. So we need to replace these velocity terms with the momentum terms. This is our target. And how we can replace it? Because we know if we are having the Lagrangian given to us by using the formula that is P is equal to delta L upon delta Q dot. And as per our question, PC is equal to delta L upon delta R dot. Okay, by using this formula, we will be able to get the relation between the R dot and PC, and that's how we will be able to replace this R dot in terms of PC. So this formula is going to help us here. Now, what is going to be the expression we will get after simplifying delta L upon delta R dot? So here in place of V, you can consider R dot square. Here also you can consider R dot. So what will be delta L upon delta R dot you will get? That will be 2R dot, 2 upon 2 cancel out. So MR dot, okay. Then from here you will get it plus CR, okay. And what is that? That is PC, momentum, okay. Now from here you want to get the R dot value. What it will be? PC minus CR upon M. Clear? PC minus CR upon M is the R dot value you have got. Just put it here in this expression. PC minus CR upon M. Clear? That is what? R dot value. So put it here. PC minus CR upon M into PC minus M upon 2. Again, PC minus CR upon M whole square minus CR PC minus CR upon M, okay, plus VR. Clear? Now, let's simplify it. As I have told you, if you will take the simplification steps very carefully, after focusing on this thing, what kind of expression you want in the final answer, your answer steps will be more simple, more easy. If you will take the wrong steps, it will be very much complicated. So we have to be extra careful at this point that what are the steps we are going to take now. See, if I'm going to talk about the next step, I can see that PC minus CR upon M is present in this term, in this term, in this term. I'm going to take it common just for the simplification part. M upon 2 into PC minus CR upon M, 1 will be remaining here, MM cancelled out. So I will just get, okay, have a look at this. PC upon 2 plus CR upon 2. From the last part, I'm going to have minus CR and plus VR. That's it. Clear? This will give you 1 PC minus half PC. That will be half PC remaining. 1 minus half is half. So you will get PC minus CR upon M, half PC, half CR minus CR, 1 minus half minus 1, so minus half. Clear? Plus VR. So PC minus CR you got. It is not in the suffix, it is like just multiplied. PC minus CR here, half you can take common. So PC minus CR, you can make it a square. So you will get PC minus CR whole square upon 2M, because 2 you will take common from the second bracket, and that's gonna be your final answer. PC minus CR whole square upon 2M plus VR. Let's check it out. In any option it is present. See, PC minus CR upon 2M and PC minus CR whole square upon 2M plus VR. That is option B, and this is the correct answer. Is this clear to everyone now? If there is any doubt anybody is gonna have, please mention it and let me know if everything is clear. Let me know, is there any doubt or is everything clear till this point? If everything clear, I'm gonna give you the next question. SK, whenever you get time, you can start preparation, okay? And don't wait for like completing your course and after that you will start preparation. If you are getting time in between and you think you can devote some time, okay, even half an hour, 1 hour, so utilize that time and you can start your preparation then. Done? That's very good, everyone. Can I give you the next question? Done. Clear? Let me just give you the next question right now. And that's too from the GATE exam we will have. Okay, it's here. And if anybody will have any doubt, you can mention it. Okay, you can let me know about it. A particle of mass m slides under the gravity without friction along the parabolic path that is y is equal to ax square. Okay, as shown in the figure. So I will show you the figure here. Okay, something like this. There is a particle and it is moving in this direction right now, and the mass of the particle is m. This is the y-axis, this is the x-axis, this is the direction of gravity. The Lagrangian for this particle is okay. Options are L is equal to half m x dot square minus mg ax square. Option B is half m 1 plus 4a square x square x dot square. Oh, it was with it's correct. It was outside the bracket itself. Minus mg ax square. Clear? Option C is half mx dot square. I will show you the above, like the statement and everything, if somebody wants to observe them once again. Half mx dot square plus mg ax square. Option D is, that's gonna be half m 1 plus 4a square x square x dot square plus mg ax square. Please try it now and let me know once you will get it done. If something will not be clear, you can tell me about it, and if everything clear, that's very good. And once you're gonna get the final answer, you can mention it in the comments which one is correct according to you. Very good, Arindam. And if anybody will have any doubt, I will discuss, so don't worry about it. And if you know some approach, some steps, start working on them, okay? And try to get the final answer. Very good, Ritika. Two answers till now. Very good, Mariam. Very good, Kaku. Very good, Abdullah. Okay, so till now everybody's answer is like same. And is there anyone who is not getting the answer and who is having some difficulty in getting the answer? If yes, please let me know. If no, that's good. So is there anybody who is not getting the answer and wants me to discuss it? Or is it clear to every one of you? Excuse me. Okay, Neeraj, let's talk about it then. See guys, if I'm going to talk about the question is a particle of mass m slides under the gravity, okay, without friction along the parabolic path y is equal to ax square. Then they have shown us the figure, okay, that this is the particle and this is how it's going to move. Now, next thing, they are just asking us to find the Lagrangian, okay, as per this information which they have given us for this question. Now, we all know in general what is the Lagrangian. Lagrangian is L is equal to T minus V. Okay, Lagrangian is what? It's gonna be L is equal to T minus V. Clear? Where T is what? T is the kinetic energy. What is V here? That is the potential energy. Here they have given us the x and y coordinates or the expression in terms of x and y coordinates. So we all need to know that when we say the kinetic energy, in general it is half mv square, or in terms of x and y coordinates it is half m x dot square plus y dot square. Done. Now if I'm going to talk about this thing, this is the kinetic energy expression for the 2D case, that's too in the Cartesian coordinate system, which means in terms of x and y. Now here they have given us the y value, which is ax square. So if I will find y dot, dot means with respect to time you are differentiating it. Clear? So what will be the y dot value from here we will get? That will be differentiated with respect to time. You will get 2ax and x dot. Clear? 2ax and x dot. Because once you will differentiate x square with respect to time, you will get 2x. Again you will have to differentiate x. So it will be dx upon dt, which means x dot. So you will finally get 2ax x dot as the y dot value. Now what you need to do, you need to put that value here. So when you are going to put this value here, you will get half m x dot square, okay, plus what is y dot? 2ax x dot. So 4a square x dot square. You can take x dot square common. So you will get half m 1 plus 4a square x square and take the x dot square common. Clear? This is how you are gonna get it. This is what? This is just the kinetic energy. Since the particle is above origin, okay, at some height above the origin, it's not below, so the distance covered will be positive. Okay, distance covered will be positive as a vertical height covered. Done. The second thing, because it is moving in the same direction as the gravity acts, so due to the gravity also its sign will be positive. So I am talking about the potential energy formula, which is mgh, or h here is the y-axis, the vertical axis y. What is the y value? That is ax square. Put it here, mg ax square. So when you will put the values here, you can directly say L is equal to what? t, this is the t value we have got, minus v. What is v? V is gonna be mgax square, and you got your final answer. Is this clear to everyone? And you will see that now this expression is gonna match with option B, and that is the right answer. Is this clear to everyone? Clear? So this is how you can simplify it, solve it, and get the answer. Is this clear to every one of you? And focus on each and every point, each and every aspect, that how we are taking sign, how we are taking potential energy, how we are writing kinetic energy. Okay, why it has happened in this question in this way, what was the reason? Focus on everything. Okay, and then whenever you are gonna consider any such type of question later on, you will find like, oh, I know everything about it. You will have that confidence. Can I give you the next question? One more, just one more last question we are gonna consider right now. Okay, done? Let's quickly take that one. Exactly after this class, our class of electromagnetic theory will start. In the description box of this video, there will be the link for the free live classes or the special classes. You all can join that session too. In January, on the everyday basis, we are gonna have like many special classes going on. Clear? So like right now, I am gonna conduct the special classes or the free live classes in the afternoon 1 o'clock and in the evening at 6 o'clock. So if you were not attending these sessions till now, you can attend these sessions too and don't miss them. Clear? And because we are gonna cover many important concepts there as well. If any one of you is going to join these sessions for the first time, you will have to use a code to join the session. The code will be exactly same, that is Anjali Arora as mentioned here. Okay, no space in between, spelling should be same. That's how you need to write it and apply it. By joining for joining the special classes, you can use the same code as well, and you can join the special classes too. Okay, now let's start the discussion about the next question. I'm gonna give you the question here. If you are going to have any doubt related to the previous concepts or the questions we have considered, please mention it in the comments. I will just talk about it as well. Here is your next question. This is again from the GATE exam. A particle of mass m, and all the questions I have discussed in today's session were from the GATE exam. A particle of mass m is attached to a fixed point O by a weightless inextensible string of length A it is rotating under the gravity. It is rotating under the gravity as shown in the figure. I will draw the figure here. The Lagrangian of the particle is L theta dot theta comma phi, which is a function of theta and phi. Theta comma phi is equal to half m a square theta dot square plus sine square theta phi dot square minus mga cos theta. Now you need to find the Hamiltonian here, and the figure given in the question is in this way. like this is the point O, this is the z-axis, okay, this is how it has been given, the path, how it's moving, straight lined, particle, mass m, okay, A, this is theta, that's it, done, direction shown here, that's it, okay, and the gravity will act in this direction. Now the options are, just a second guys, yeah, now the options are, you need to find the Hamiltonian here, okay. So instead of writing the options, I'm just directly gonna tell you something in this question that will be a trick, clear, and which will help you to answer such type of questions easily and in very less time. So let me just tell you that trick first, and then this is how we are gonna end today's session, clear. So guys, if I'm gonna talk about the trick is, if the Lagrangian is given to you, we all know Lagrangian is what? It is gonna be a function of generalized coordinate and generalized velocity. So here generalized coordinate and generalized velocity. So here theta and phi, two coordinates are present, two velocities, theta dot and phi dot. If in any given question in Lagrangian, it is possible for you to compare or to consider the kinetic energy term separately and the potential energy term separately, if it is possible, and you are able to identify that, okay, this is kinetic energy term, how you will be able to identify? Compare the kinetic energy terms with half mv square if it is Lagrangian given to you, and you can see it will be the potential energy term in the form mgh. So h will be the a cos theta component, okay. Now the point is, yes, it is possible for us to compare it here. For the first term, when we are gonna have half ma square theta dot square, so theta dot is velocity, so this is mass, okay, this is m. Similarly, you need to compare the second term. It will be half ma square sine square theta and phi dot square. So it will be what? Again half mv square. So this is m. What you need to do to write the Hamiltonian now, this is how you will compare first, and do only when it is possible for you to get sure that it is kinetic energy term, it is the potential energy term, and you can compare. Then Hamiltonian will be p theta square, because of theta this, upon 2m. What is m you have got after comparing? ma square, write it here, plus p phi square because of this component, okay, momentum corresponding to that, upon 2m. What is m you have got? This was the m, ma square sine square theta, okay, and then plus v, okay, because in the Hamiltonian t plus v, so plus mga cos theta. That will be your final answer. This is how you can write any Hamiltonian expression if the Lagrangian has been given to you, okay. So guys, this was the discussion for today's session. I hope everything will be clear to all of you. So many important concepts and questions we have discussed in this session today. Also guys, as I have provided you the information about the Unacademy Plus subscription and the important courses, so if you want to attend the more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription also by using and by applying the referral code, which is Anjali Arora. As mentioned here, you will be able to get the 10% discount in the total Unacademy Plus subscription amount. Clear? And also guys, exactly after this class, our electromagnetic theory session is gonna start. You all can join that session. All these updates I have already provided you in the starting of the session too. So thank you so much everyone for joining this session. Thank you. And now you all can join our special class, okay. In the description there is the link given to you. Thank